This video is going to be about a very handy equation that comes up in some situations, and we should know it and we should know how to use it. So let's set up a situation here. We're going to talk about an acceleration problem. So I'm going to have a car. There's my awesome car. And I'm going to have it have an initial speed of 40 meters per second. And then the car is going to come over here and it's going to come to rest. There's my awful car again. And over here, its speed is going to be 0. And this time, I'm going to tell you the distance the car traveled as it came to a stop. We'll just say it's 100 meters. And the question I want to figure out is, what was the car's acceleration? Right? So if you're looking through some problems or some equations, you might say, okay, cool, and a good equation to use is velocity and acceleration in the same equation. So I might say v equals at plus v0. You think, gosh, I don't know the time, so how can I figure out the acceleration? You think, okay, well, another equation I know has distance and acceleration in it. So you might think, oh look, x equals 1/2 at squared plus v0t plus x0. I know the distance, but I don't know the time, so how can I figure out the acceleration? Well, there's a couple ways that we can do this, and one of them is with this handy equation, but I'll show you without the handy equation how you can do it, and then I'll show you the handy equation. I'll give you the same actual answer. Because another equation we can work with, this is not the handy equation, we can do average velocity times time. I know that x is 100 meters, and I can figure out the time if I could only figure out what the average velocity was. Well, average velocity is actually really easy sometimes. If I happen to know my two velocities, I have a 40 and I have a 0. So if I want to average 40 and 0, I can add them together and divide by 2. So my average velocity is actually going to be 20 meters per second, right in the middle of those two. Makes sense. Now I can use this equation over here. I know my x is 100 meters. 100 meters equals 20 meters per second times the time. Now I can actually find the time. The time is going to be 5 seconds. Great. Now I can go back and I can choose either one of these equations to plug it back into, and then I can actually figure out the acceleration based upon that. Let's take the long way around, just because, I don't know. And let's use this number and plug it back into that equation up here, using this to plug into there as well. And ultimately, we're trying to figure out what's the acceleration. Okay, so let's try it out. So I'm just going to rewrite it down here. I have 100 meters is 1/2. A is my unknown. T is 5 squared, plus my initial velocity, 40, times time, and I don't really have an initial position here, so I don't need to include that. And now I'm just, times the time, sorry, the time is 5 seconds, because I already know the time. Now I just need to solve for A, so this is just algebra. I'll drop my units. 100 is, that's 25, so that's 12.5A plus 200, negative 100 is 12.5A, A is negative 8 meters per second squared. I could have gotten the same thing from here as well. That was kind of a pain. So here's my final answer. Now let me show you the handy equation. All right, this is going to be quite useful, and you should recognize it. I'll give it to you on quizzes and tests so you don't have to memorize it. But here's our handy equation. It's going to be great. You're going to love it. Here it is. V squared is v0 squared plus 2 times A times change in position. What's cool about this equation is it actually doesn't have time in it. There's no time. So when you're faced with a problem like this, where you don't have time, but I know my final speed, I know my initial speed, I'm looking for acceleration, and I know my displacement right here. My displacement was 100 meters. So let's plug it in, and hopefully we'll get the same answer as we got from doing it the long way around. This is my final speed. That's 0. Right, my final speed right here. This tells me what my final speed is. So I have 0 squared equals, I'm going to drop my units just to make it a little neater, 40 squared plus 2 times a, that's my thing I'm looking for, times 100, right? 40 squared is 1600, bring it over to this side. Let's see, 1600 equals, negative 1600 equals 200a. So that's going to give me a is negative 8 meters per second squared. Right, so that's pretty handy to be able to do that. Let's look at another example where you might try to put this into practice. And that has to do with gravity problems and free fall problems. Right, so here's another situation where this might actually come in handy. Let's say that you are standing on the ground and you are throwing something in the air, and you have an initial speed that's a little bit off. And by off, I mean it's not a multiple of 10. So it's going to be a little harder to deal with our sort of sense of what gravity does. Let's give it an initial speed of 45 meters per second. And the question is, how high will it go? How high? At the very peak. What's the very top? Right, assuming it's just starting right here down at the ground. How high will it go? Well, looking back at our other equations, we've got our x equation that does this. 1/2 a t squared plus v0 t plus x0. But you know what? It's hard to use this equation when you don't have the time. I know the acceleration is going to be 10 or negative 10, but I don't have the time. So that's a problem. Let's use our new handy equation. V squared is v0 squared plus 2 times a times my displacement. Right? Look. Final speed, initial speed, acceleration, no time in here. Let's plug it in. Let's see if it actually works. Now, one of the tricks here is if we're figuring out how high it goes, what we need to realize is that at the top right here, my speed is going to be 0 at the top. So I'm going to actually plug in 0 right here. Right? I also have to agree upon which way I'm going to choose as positive and negative. So I'm going to just go ahead and call down as negative, down as negative and up as positive. That'll just help me keep things straight over here when I plug numbers in for a. Alright, so solving this one out, final speed 0 equals initial speed in the up direction, so that's positive, 45 meters per second squared plus 2. Now I'm going to plug in negative 10 meters per second squared for gravity times my displacement right there. Alright, now I get a little calculator going on, and I have to do 45 squared, so that gets me 0 is 2025 plus, minus 20 times delta x. So moving things around, I can say 20 equals 2025. Divide that by 20, and I get my delta x is 101.25 meters. That's way too many sig figs, but don't worry about it. So once again, this is my handy equation. Comes in nice, works out really well. Let me just backtrack here and I'll show you that you could actually figure this out without the handy equation using our average velocity formula. X equals average velocity times time, right? And then you can also use this equation to figure it out as well. V equals AT plus V0. This equation will give me the time, and I can plug it into this equation. It'll give me the actual how far it went if I know what my average velocity is. So let's just do it so we can make sure we get the same answer. All right. What's my velocity? Well, the top my velocity is 0 equals, this is going to be negative 10 times t plus 45. Sorry, I dropped my units. And solving this, I'm going to get my time is 4.5 seconds. That's how much time it's going to take to go to the top, which actually makes a lot of sense because gravity is going to take away 10 every second. If I start at 45, 1 second later I'll be going 35, 25, 15, 5, and another half second to get to 0. So 4.5 seconds. Essentially, I'm just dividing that by 10 to get the time in the air. Now we can plug it in over here, except I need to figure out what's my average velocity, right? So let's just go over here. My average velocity is going to be 45 plus 0 divided by 2. Right? So that's going to give me 22.5 meters per second. Now we can use this formula right here to figure out how far it's gone. X equals average velocity, 22.5. Drop my units because it's getting kind of crowded in here, times 4.5. Come back over to the calculator. Oops, I forgot a parentheses. Wing. And I get 22.5 times 4.5. Bingo, 101.25. Right? Either way works. You might not think that that's actually so hard to do. This one works totally fine as well. So here's our handy equation. It can be used for gravity problems. It can be used for just general acceleration problems as well.